name's Greg Anderson, and my presentation is on compromising and hijacking build pipelines. I had a co-presenter named Kyle Kelly who unfortunately couldn't make it today, so y'all are just stuck with me. When I talk about build pipelines, what I'm referring to is source control, continuous integration tools such as Travis and Jenkins CI, and upstream sources such as like PyPI. The ideal that I kind of want to sell y'all on by the end of the presentation is that rather than focusing on an individual server, if you can contaminate the right pipeline, you will compromise a whole lot of things without a whole lot of effort. So this talk is also about people making little mistakes that we will maximize. Taking something very small and doing the most damage possible with it. And it happens a lot more often than I thought it would be. And it's not just people that are new to development. If you're familiar with Rich Mogul, he does AppSec training at Black Hat USA. And to read Rich's quote, "I did not completely scrub my code before posting to GitHub. I did not have billing alerts enabled. This was a real mistake, and I paid the price for complacency." So essentially what Rich did is he committed his Amazon access key to GitHub. Someone came along and found this key, spun up a whole bunch of cloud servers on his account, and in the post-mortem, he found out that these people were using his cloud account and billing to mine Bitcoin. So, you know, no one likes paying for other people's cryptocurrency. Yeah, that's not good. If you want to learn more about Rich's story, you can visit this short URL that I created. But I think this is a problem with the development environment that we work in today. We're all about meeting deadlines and getting things out before our competitors. So what happens in a rush to deploy code is either developers add things to their repositories that shouldn't be there, or developers blindly trust a third-party application to do a job for them without looking through the source code. So some fun you can have when these credentials get leaked, specifically cloud credentials, is you can create and destroy infrastructure, you can redistribute DNS and load balancers, you can move sensitive volumes, and in Nova for OpenStack, you can append a malicious SSH key to all cloud servers that are created after you add that key. So the next question is kind of how do we find these keys? It's really pretty simple. You can either use Google or GitHub code search. I like to use Google for finding actual files that people have committed. So all I do is I use like the site delineation, and I'm searching GitHub for the secret token file, which in Ruby is used to store sensitive credentials that your application needs to run. And then in the second one, I'm searching for RSA private keys. And you can see that there's a fair amount of results. One of my favorite ones, and this is because I don't work for Amazon, is AKIJ. It's the prefix for all Amazon access keys. So if you find these, there's a really high chance that it's not a false positive, and you can log into individual Amazon accounts using this prefix. GitHub wised up to this and has changed this. So since I did a talk very similar at DEF CON, and since then they've done some additional filtering on specifically this keyword. So if you search for this now, you won't get any results. But that's okay, because there's still a whole lot more you can search for. Another great one is OS password, which is short for OpenStack password. So if you wanted to compromise cloud servers on IBM, HP, or Rackspace, this is probably what you'd want to search for. Another one that I found interesting is API key. There's a whole lot of false positives, but I also got some really interesting results from digging through this. But my favorite is GitHub token, because if you get one of these, you can masquerade as a developer through all of their repositories. So now we have all these keys, right? We're ready to go out and compromise thousands of servers and do horrible things on them. How many people here use AWS? Anyone? No, one person? Okay, so let's say you're all excited and you want to use this Amazon access key prefix to hunt down and start doing things right this second. I don't see any laptops opening, which is good. But you might go to the AWS login page and you'll be, oh man, I have this key, but where the hell does it go? What you actually have to do is use the API, and it's kind of an extensive process to compromise your first server. So essentially what you have to do is first, using the access key, create a key pair, add it to your own server, then freeze the server you want to compromise, unmount the volume, attach that unmounted volume to your server, add your private key, remount the volume to your original server, and then you can unfreeze it. So that's like a lot to say, but it's super easy to script. The problem, though, is since this has been going on for quite some time, is Amazon has wised up and really stepped up their monitoring. So if you freeze a production server, the developer is going to know instantly. So if you just want to smash and grab a whole lot of stuff, this is great. But honestly, there's a lot better things that you can do with it, which leads us to targeting CI tools. So does anyone use Jenkins or continuous integration tools? Awesome. Okay, so if you don't know what Jenkins is, it's a continuous integration and deployment tool used to not only test code, but also to deploy it. And the reason we want to compromise Jenkins is because it's essentially the road to production. At the end of every Jenkins instance is either a code repository being used by multiple servers or a production server with information worth stealing. So this is what a typical Jenkins build looks like. We have a code repository that goes through smoke and regression testing, and then if both those suites pass, it's then deployed to production. So essentially what we want to do is masquerade as hipster developer so we can compromise whatever is at the end of this pipeline. So let's say that hipster developer makes an oops, and he commits his GitHub token into a public repository that I find. I mean, it's pretty much off to the races. You can be as creative as you want with the vulnerability that you put in his code. But in the first scenario, when there's just a code repository you're infecting, you want something that is easy to detect and scan for, but is also easy to use. So I think buffer overflow would be like my choice. But again, it's up to you and your creativity. If it's a production server, I think more about persistence. I think about reverse shells to try and bypass firewalls and exfiltrate information. So how credentials and secrets are actually stored in Jenkins is either through the actual deploy script or the credentials plugin. But at runtime, it doesn't matter because they all are passed as environment variables. So the first thing I wanted to try in potentially hijacked code is an attempt to phone home the environment variables. And that's really easy to do without any problems. So this is great and awesome, and it will give me one of the servers that our continuous integration tools are potentially interacting with. But like compromising one server is kind of, it's okay, it's nothing exciting, people do it every day. What's really cool is compromising all the servers that this piece of technology is connected to. So in order to do that, we have to try to target Jenkins directly. So I did a whole lot of digging, more digging than I want to admit. And if you're using the Jenkins user database, all your users are managed in this directory called varlib Jenkins users. And each user has a configuration file that looks like this. If you can't really see it, there's a password hash that's using JBcrypt. So I did some more digging, and I dug down to this file called Hudson Private Security Realm, where we learn how Jenkins is encoding passwords and how it validates them. The problem, well, it's not really a problem, but it's very easy for me to create hashes that would be validated by this piece of technology. So the next thing I wanted to try is what if something like this was maliciously entered into the code. The goal of this code is to enumerate all the users that are in the Jenkins database and then change their password to a password of my choice so that I can log in as anyone and then dump all the credentials. Let's give it a try. So over here, I have my potential code that I have now access to from compromising the GitHub token. And to show that I'm not cheating, I need someone to pick a password. Be brave. Sure. Sparkles. I definitely did not make my password Sparkles to start with, right? So now we have our bcrypt hash that we can attempt to pass through the pipeline. Oops. Oh. Cool. So up until this point, oh, I didn't start it. No. I have to start my malicious server so I can get data back. Ooh. Cool. So up until this point, I don't actually know where the Jenkins server is, but you'll see it's doing this potential build over here, and it's running through my code. And at the same time, you'll see in our malicious server, we've just received an IP address and 3 users. So I'm just going to pick admin because I'm lazy. Maybe. Oh, it scared me for a second. And what was the Skittles? Sparkles. And so now we have full access to the Jenkins box, which after this, it's kind of arbitrarily easy to dump all the credentials, not just for one build, but for everything it's connected to. And at that point, you're home free. So there is kind of a catch, though, to this attack vector, and it's that it has to run on the master node of Jenkins, which most people are already doing, especially because these builds are kind of costly. So if they're not running on multiple nodes, this is kind of the default. But if it is like a huge deploy and they do have slave nodes, there is ways to force yourself to the master to cause this attack to execute and compromise the Jenkins server. And one of the ways to do that is if they allow concurrent builds to execute, all you have to do is add a sleep function in the malicious code. So you just keep recommitting and pushing this code, and it makes each node sleep, each slave node sleep until you're on the master node. If they don't allow concurrent builds, you have to get a little bit creative. So your options are to monitor for other commits that are being pushed and other jobs that are being built so you can try to land on the master. So essentially you're just trying to land on like a bullseye, it's like playing darts. Or with the compromised credentials that you have, you can push to other repositories and try to trigger builds concurrently that will allow your malicious code to propagate. But what if there aren't any like security oopses? What if we just want to compromise a repository because we know 1,000 people use it or 100,000 people use it, or at the end of this pipeline is a server with information that'll get us halfway to buying our own yacht. In some cases, developers are doing automatic pull request building. And essentially what that does is Jenkins will take the pull request, automatically run the code to see if it's functional and if it passes performance standards, and then it'll report that information to the admin. So that sounds kind of stupid to us as security people because we know that we should never run code that we haven't looked at. But to a developer that's managing a huge code base, it can be very helpful to helping him properly utilize his time. More likely, though, you'll hit the gate, which means that you'll submit this pull request and you'll get back this comment saying, can one of the admins verify this patch before the code is even run? So pressing forward, you have two options. Being sneaky is nothing really new. You have to either obfuscate your code in a way that the malicious code isn't easy to see, or you have to make it so small that it goes by undetected. A good example of that is it can be as simple as yank paste, which if you use Vim, copies and pastes a line. This is the old code for iOS verify SSL certificates. And you'll notice there's an extra go to fail, which causes it to fail every time. So there's also this notion of just forcing Jenkins to build, because all it is doing is waiting for a post request that says, hey, there's new code that you need to test. And supposedly, Jenkins verifies that there's actually a new pull request that's legitimate and authenticated by an admin. But it's literally just a post request. So if you can forge it, you can force any instance to build regardless of their settings. This is something I wanted to do more research on. But I went to Hawaii, and I discovered that I like Mai Tais more than I like research. So if anyone plays with this, I'd love to hear from you. If not, maybe I'll get some free time. But the worst case scenario, right, is even if they're not using continuous integration tools, you just commit something small that could be malicious, and you wait, and you hope that it propagates. And if it does, you go, you scan for it, and you compromise every single server that gets touched by the code. But so I put a quick overview on things you should do to secure your CI tools. Disable anonymous access, gate your deploys, use random port for slave communications, disable executors on master, change your webhook from the default URL, and it's that easy. But one question that kind of came up when me and Kyle and I were doing this research is, can't we just let people know when they screw up? And it turns out that there's a lot of people trying to do that, but they don't do it very well. So this is an email that some security researcher sent out. And you'll notice, basically, he said, oh, we've confirmed this exploit manually. And then you look down, and this is clearly not something that's being leaked. So Kyle started this project called GetSecNanny. Its job is to search repositories for security oopses, email the original committer and owner of the project, let them know how to revoke keys, and then panic. The responses were kind of varied. Some people were really thankful, and they wanted to know how we actually found these issues. Other people were like, well, it's a testing project, so I don't care. But there's not really such things as like testing credit cards, so still useful for me. I don't even own this repository, or doesn't matter, I'm not using the account. So far we've done, last time I talked to Kyle, he's verified and notified 265 people of these keys we found. That's not good. That's a lot of keys. That's all that I got. Man, there's so many out there. Like, people like to talk about how cool 0 days are and all that. But if you go to Google right now and just start searching, or if you go to GitHub and just start using code search, man, like you'll be set for days. You will never need another computer for as long as you are coding. If I can get back to it, maybe. Yeah, so the numbers are pretty astonishing. Like, so for secret token in Ruby, 3,400 hits. Those are going to be, I would guess, few false positives because it is an actual file that they're committing. You can't really have like a false secret file. 1,000 Amazon servers. Oh yeah, so GitHub and Amazon have gotten a lot smarter about this. GitHub is trying to no longer index possible secrets. So their goal is whenever you actually use code search, you won't get any results back. So they're definitely getting smarter. Amazon is actually doing the same thing that we're doing, and they are actively scanning and notifying their customers. So it's definitely trending down, but I don't think it's trending down because our practices are getting smarter. I think that we're just panicking a little more. Good. Great. Thanks, guys. Appreciate y'all coming.